I want to engage you with a demo of the electroscope. And I built this in my garage this weekend. I have a little chemistry set in my garage. So there's a little flask, a rubber stopper, and a metal rod. And then the custom part of it is these two metal leaves that hang down. So let me demonstrate what happens when you use the electroscope. And all we're looking for is for these wings to spread apart or not. And there will never be the situation where they come together and touch each other. Maybe you can think about that for a minute. Think about why that would never happen. They're either totally relaxed or they spread apart to varying degrees. So I'm going to charge this balloon with some wool. As I've told you before, the theory is that electrons are coming off of the wool and being deposited onto the balloon. So this is getting a pretty hefty charge on it right now. And you can see that as I get the balloon near the electroscope, the leaves start to spread apart. All right, so I've drawn some pictures and on the board, and I'll go through these with a red and a green. I've removed the flask and the electric stopper because the important part of this is just the conductor down to the leaves. So in the uncharged state, the leaves are just hanging straight down. There's as many positive charges as there is negative charges on the electroscope. So I've just drawn an equal number here. Now, if I were to charge a wand or charge a balloon, and in this case it would be a plastic stick is what I've shown in the picture. If I were to charge that and bring it close to the electroscope, then what happens is any negative, well, I'm actually going to charge it by contact. So I'm going to bring it close and I'm actually going to touch it. So any positive charges that are in the electroscope are going to find their way to the more negatively charged source, external source that's in contact with it. But mostly what's happening is that the negative charges that are on this plastic rod are going to be deposited, charged by contact, are going to be deposited on the electroscope. Now, since this is a conductor, the charges are free to move, so they'll evenly distribute themselves from the tip all the way down to the leaves. So if both leaves have the same charge, what happens to the leaves? Like charges repel, right? So the leaves spread apart. Then if you take the wand away, the plastic stick away, you leave this thing with an abundance of negative charge. And this is what we call a charged electroscope. Okay, so who cares, right? So we have this thing and its legs are spread apart. What good is that for? Using an electroscope to determine charge. Now we have something, we have a little test probe. Now if we want to know what the charge of something is, we can bring this close to that and see what happens. So in the case of bringing this close to a negative charge, what happens is that like charges repel, so negative charges will be pushed away from the tip, further down into the leaves. More negative charges on the leaves cause the leaves to spread apart farther. For the other case, if you bring it near a positive charge, then the negative charges are going to go up into the tip to try to get close to that external source. The positive charges are going to go down into the leaves, which reduces the number of like charges down in the leaves, and then they're going to relax a little bit. So you can tell with a charged electroscope whether you're getting near a positive charge or whether you're getting near a negative charge. The old TV screens, before we had flat screens so much, we had these big tubes. And you remember that, I don't know, sometimes when you turned it on and turned it off, there would be this crackle. The front of that screen was loaded with positive charge. And if you would bring an electroscope, a charged electroscope to it, you could determine what charge that was. That's how an electroscope works.